Okay. So how's everyone still feeling?
Not so good.
Let's take a look at this question. Lesson 2, focus on concept question number 6.
What page?
So this is page 81.
Are you recording?
Yes.
Oh my.
So it says here, ball 1 is thrown into the air and it follows the trajectory for projectile motion shown in the drawing. Okay. At the instant that ball 1 is at the top of its trajectory, ball 2 is dropped from rest from the same height. Which ball reaches the ground first? A, ball 1 reaches the ground first, since it is moving at the top of its trajectory, while ball 2 is dropped from rest. B, ball 2 reaches the ground first because it has the shorter distance to travel. C, both balls reach the ground at the same time. D, there is not enough information to tell which ball reaches the ground first. So, Michelle, both balls reach the ground at the same time? That's your answer? Roger?
What was going on?
Which ball is going to land first?
Oh, same time.
Same time?
Yeah.
Jeremy?
Yeah, same time.
Michelle? Sure.
We better land at the same time.
Jeffrey?
Can you repeat the question?
Just basically, you see those two balls right there, yes?
The horizontal component doesn't affect the vertical one.
This ball here is thrown and it goes like that. You see what I'm saying?
Yeah.
It's thrown, it follows that parabolic shape, goes like that, upside down parabol. Right when it gets to the top right there, yes? A second ball right here is dropped. Which one hits the ground first? The one that's just dropped? Or the one that was on its way? So this one is thrown back. Right when I said back, this one over here was dropped. Which one's going to hit first?
I will say one, but I mean another. See. What? We don't know the answer.
Don't be cryptic. Just give me an answer.
I like being cryptic. It's fun.
Well, here's the thing. If you take a close look, at this particular point right here, this projectile definitely has a horizontal velocity. How fast is it going? V sub x, whatever that may be. But right at that point right there, how fast is that projectile going down? Or up for that matter? What is the velocity in the y direction right at that top point?
It shall be zero.
Better be zero.
It shall be zero. It is not better be zero.
Right at that top point, the ball is going to be going horizontally, yes? But vertically speaking, it's not going up or down. You know, here it sort of had an upward part. Here it had a smaller upward part. Here it had even a smaller upward part. Right there at that point right there, its velocity up and down in the y direction is 0. What is this ball's initial velocity in the y direction? Right? 0 meters per second. So basically, how does the vertical motion of this projectile, as it's doing this, compare to this vertical velocity as it's dropping straight down? What's the difference?
It's got to be the same.
In house school.
Yes? Yeah, exactly. This velocity here, perpendicularly, that has no effect on how fast it's going down, and they're both starting from rest in the vertical direction, so basically it takes the same amount of time to drop here as this one here would take to drop down there. So, same amount of time. Any follow-up questions to that? You guys good with that?